Alright, so this is part 2 of section 3.4, exponential and logarithmic equations. And just as a quick reminder, the essential question is, how do I solve logarithmic equations? Okay, so first we're going to look at is example 5, and we're going to solve an exponential equation. But here we're going to use the factoring technique. And the first thing I want to show you is, just as a quick reminder, e to the 2x can be rewritten as e to the x and then in parentheses squared. And the reason we can do that is I can write this term as e to the x times e to the x. And then if you remember, anytime you have the same base, okay, we just add the two exponents, and that's why it becomes e to the 2x. Okay, so we're going to apply that same principle here to the problem we have. So what I'm going to do now is I'm going to rewrite the equation here, but instead of e to the 2x, I'm going to write it out as e to the x squared minus 4 e to the x plus 3 is equal to 0. And as you get better at this, you can factor this very simply, but let's just make this quick substitution, saying let's let y be equal to e to the x. I can now rewrite the equation as y squared minus 4y plus 3 is equal to 0, and this can be very simply factored into a pair of y's, and both signs are negative. So we have y minus 3, and the quantity y minus 1 is equal to 0, and it's in factored form. And now what I'll do is I'll substitute e to the x back in. So now we just look at each of our products separately and set it equal to 0 to solve for x. So here we'll start with e to the x minus 3 is equal to 0, or e to the x is equal to 3. If we take the ln of both sides, we'll find that x is going to be equal to the ln of 3. For the second one, if we have e to the x minus 1 is equal to 0, and I'm going to move it to the other side and take the ln all in one step. So I'm going to end up with x ln e is equal to ln of 1. Well, I know the ln of 1 right here. This is equal to 0, so here x has to be 0. So the two solutions for this problem are x is equal to 0 and the ln of 3. Okay, so what I'd like you to do here is try checkpoint 5. Go ahead and pause the video, and then after you finish it, unpause it to see the solution. Okay, so here, again, we just did the same process. So we substituted e to the 2x with e to the x and then squared that whole term. And then I did that y substitution and factored y squared minus 8y plus 7 to y minus 7 times y minus 1, and then resubstituted in, and then took each linear factor and solved. So I got x is equal to the ln of 7. I solved the second one, and of course x is 0, so the two solutions are 0 and the ln of 7. So now we're going to look at what happens when we need to solve some logarithmic equations. And when we do that, one of the tools we can use is to change our logarithmic equation into an exponential and solve from there. So when we look at this example, I'm looking at a says the log of base 4 of x plus 3 is equal to 2. The first thing I want to do is I'll rewrite it first. So log base 4 x plus 3 is equal to 2. I want to go ahead and rewrite this. So this becomes 4 squared is equal to x plus 3. So 16 is equal to x plus 3. So x has to be equal to 13. So that's the first solution. The second one is just slightly different. So B is, first thing I want to do is I'll start with the 3 ln of 2x is equal to 12. I'm going to divide both sides by 3 to get the ln of 2x is now equal to 4. And now I'm going to go ahead and turn this into, so e to the 4th power is equal to 2x, or x is equal to e to the 4th plus 2. And you could do a decimal approximation, but for this purpose, e to the 4th over 2 is a sufficient answer. Alright, so take a couple seconds, try checkpoint 6, pause the video, and then when you unpause it, you'll see the solution. Okay, so just like the last problem, we start with the log base 2 of x minus 4 is equal to 3, and we convert that into its exponential form, or 2 cubed is equal to x minus 4. And then doing some very simple algebra, we're able to ascertain that x is equal to 12. For the second example, remember the first thing we had to do is get the natural log by itself, so we divided both sides by 4 to get the ln of 3x is equal to 2. And this turns into e squared equals 3x, and then through algebra we get x is equal to e squared divided by 3. Example 7 is fairly similar to example 6, but first what we have to do is we need to use the product rule to combine the two logarithms into one. And when I do that, I get log base 2 of x times x minus 7. And that, of course, is equal to 3. So when I set up this exponential equation, I get 2 cubed, and I'm going to go ahead and expand this out, so it's x squared minus 7x. And now when I solve this, or set the left side equal to 0, which I'll write on the right-hand side, I get x squared minus 7x, and then minus 8 is equal to 0. And now we just factor. So this just becomes x minus 8 and x plus 1. So remember, it's the two numbers that multiply to negative 8, but add up to negative 7. Okay, so the two solutions here are x is equal to negative 1 and x is equal to 8. Alright, this next example has some similarities to the last one, and then it changes. So the similarities for the last example is the first thing we need to do is we need to combine our natural logarithms on the left-hand side. So here we have the ln of x plus 2 minus the ln of 4x plus 3 is all equal to the natural log of 1 over x. So if I use the quotient rule and combine the two logarithms on the left-hand side, I get the ln of x plus 2 divided by 4x plus 3 is equal to the ln of 1 over x. So now what I see here is I see the natural log equaling some other natural log, and because of that, I'm allowed to equate this inside to this inside and drop the natural logs off. So when I do that, I get x plus 2 over 4x plus 3 is equal to 1 over x. Okay. And then here, if I cross multiply, I'm able to simplify that further by doing x times x plus 2 is equal to 4x plus 3. And then using some algebraic simplification, I'm going to multiply this out and then move that to the other side all in one step. So I get x squared plus 2x minus 4x minus 3 is equal to 0. And then I get x squared minus 2x minus 3 is equal to 0. If I factor this out, I get x minus 3, x plus 1 is equal to 0, because remember, it's the two multiples that multiply to negative 3, but add to negative 2. So this tells me the solution is negative 1 and positive 3. Okay, so in this section, the predominant type of application problem we're going to see is using the interest formula. And typically what we do here is we either solve for some sort of time and figure out how long it takes to grow a certain investment account. So in this problem, we want to see how long it takes to grow 25,000 to 500,000 using 9% compounded monthly. So the very first step here is to just set it up. So we get 500,000 is equal to 25,000 times 1 plus, and my interest rate is 0.09 over 12, and then 12t. So I need to solve this equation for t. So the first thing I have to do is divide this over. And when I do that, I get 20 on the left-hand side is equal to, and in parentheses, if I simplify that, I get 1.0075 is equal to raised to the power of 12t. Now I take the natural log of both sides, so I get the ln of 20 is equal to 12t ln of 1.0075. So now, if I divide over this 12 and this ln of 1.0075, I get t is equal to the ln of 20 divided by 12 ln 1.0075, and that's approximately equal to 33.4. And now, because it's interest, the t is going to be in years. So what that means is it's going to take 33.4 years to turn $25,000 into $500,000 at 9% interest. So for checkpoint 10, try the same steps and see how long it'll take to grow 1,000 into $3,600 at 8% interest compounded quarterly. Pause the video, have a go, and then you can unpause it to see the solution.